What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 4.5, dilations. What we're going to be able to do with dilations is identify and perform them, and then also solve some real-life problems involving scale factors and dilations. The first thing we want to talk about are all of our vocabulary terms. A dilation is when a transformation is enlarged or reduced with respect to a fixed point C. The center of dilation is that fixed point of dilation. The scale factor is a ratio of the lengths of the corresponding images of the image and the pre-image. So the image is the new and the pre-image is the original. Okay, so how I like to remember this is you're going to say just say no, and that's going to be your ratio for your scale factor. That's new to original. Okay. The next thing we want to talk about are the different types of scale factors. So we have enlargements, which are going to be where your scale factor is greater than 1. So you a lot of times would see k is greater than 1. And a reduction, a dilation with the scale factor that's less than 1. You won't ever get below 0, so I guess it also just needs to be between 0 and 1. So just make sure you understand it could be like 0.1 or 8/9, some type of fraction or decimal within there, and that'll tell you what type of reduction it'll be. What we're going to do first is find scale factors of dilations, then tell whether the dilation is a reduction or an enlargement. And remember to write this, we're going to say no. That means we take the new number and put it over the original number. Okay, so for the first one, we look for the new number, and it looks like P prime is that new number. So 12 will go on top over 8 is the OG. We also want to make sure that we reduce this. So we're going to reduce it by 4 and we get 3 over 2. So K is equal to 3 over 2. And this would be considered an enlargement. Okay. Pause the video, see if you can try letter B on your own. When you're done, click play to check your work. For this one, it looks like the new one, P prime, is here with 18, and the original one, just the letter P, is the 30. So for this option, we're going to have 18 over 30, and then we can reduce those maybe by 6. We get 3 over 5. This scale factor, since it's less than 1 but still greater than 0, we're going to call that a reduction. Okay. We have some coordinate rules for dilations too, so we want to make sure we understand what those are and what they look like. Then we're going to try some. If P is x comma y, and that's the pre-image of a point, and we're dilating after or around the respect to the origin, we can find the scale factor by just multiplying both the x and the y by the letter k, or our scale factor. So that's what we're actually going to try in the next section. Graph triangle ABC with vertices A, 2, 1, B, 4, 1, and C, 4, negative 1, and then its image after the scale factor of 2. So first, let's go ahead and graph our original triangle. So here's our original triangle on the coordinate plane, and all I'm going to do is I'm going to make that scale factor be 2. So that just means I'm going to take A and multiply both points by 2. 2 times 2 is 4, and 1 times 2 is 2. So we're just doubling those points. B prime would be 8, comma 2, and C prime would be 8, comma negative 2. So let's see now what those look like after we graph our new points. So here is our image now, and notice that our triangle has grown twice the size because we doubled the points on the coordinate plane. How about you go ahead and try this one? It says graph quadrilateral KLMN with vertices listed here, and then create the dilation with the scale factor of 1/3. So let's go ahead and pause the video here, try it on your own, and when you're ready to check it, click play. The first thing I did was went ahead and plotted our pre-image, so these are all of my original points. The next thing I need to determine are what are going to be my new points after taking the scale factor of 1/3. Taking the scale factor of 1/3 is like taking each point and multiplying it by 1/3. The nice thing about multiplying by 1/3, it's the same thing as dividing by 3. So I would get, for letter K prime, -1, 2. L prime would be 0, 2. M prime would be 1, 1. And N prime would be -1, -1. Let's go ahead and plot these new points and see what happens. And here we have our new figure, or the image, of K, L, M, and N prime. Notice it has been reduced by 3 times the size. Here's a different one, and it's a little bit odd because now we are finding the scale factor of -1/2. So we're going to see what happens when we find it here. Graph the original triangle with FGH and the given vertices, and then create a dilation of -1/2. So let's go ahead and pause the video here, graph the original one, find the points for the image, and then graph that one as well. Okay, so here is our original figure of FGH with the given vertices. Now what we need to do is find the scale factor of -1/2. So that means we would take like point F and say -4 times -1/2 and -2 times -1/2. When we do this, we're going to end up with a positive number now, 4 over 2, which is equal to 2. So whenever we're multiplying by -1/2, it's just like dividing by -2. So F prime will now be 2, 1. G prime will now be 1, -2. And H prime will now be 1, 1. Let's see what happens when we plot these new points. Not only has our image decreased in size with a reduction, but it now has also looked like it has been rotated about 180 degrees. So when you notice that you have a negative scale factor, negative scale factors are like a dilation and rotation of 180 degrees. Here's another one we can try, and this is just a word problem that we're going to discuss and try to work through. You're making your own photo stickers. Your photo is now 4 inches by 4 inches. The image on the sticker is 1.1 inches by 1.1 inches. What is the scale factor of the dilation? Remember, to find scale factor, we can always say no. New over original. The new one here is now 1.1 inches. The original was 4. So what we would just do is we would divide this and find maybe a decimal equivalent, because we don't want a decimal within a fraction. So we would divide that and get 0.275 as our scale factor. Okay. The last one we have, you are using a magnifying glass that shows the image of an object that is 6 times the object's actual size. Determine the length of the image of a spider that is 1.5 centimeters long. Remember, think about if your spider is 1.5 centimeters long and you're using a magnifying glass, that's going to be 6 times the amount. So you would take your 1.5 current measurement, multiply that by 6, and on the magnifying glass, the spider would come up to 9 centimeters. Okay?